Okay, so we're going to talk about the real number system. So that's what we're talking about today. Let me share this with you. I shared the Jamboard. I'm also going to share the screen so you can look at what I'm writing. So we're going to be talking about classifying numbers. Okay, so I'm going to ask you to kind of tell me what types of numbers things are. So there's a bunch of different types of numbers, but in this specific example, we're going to be dealing with natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So natural numbers are just counting numbers, numbers I can count. Okay, so let's think about the types of numbers I can count. I can't count negative items. Negative items don't exist, right? So these are going to be 1, 2, 3, 4, 5, etc. There's no decimals, no fractions involved, okay? Questions, comments, concerns about the natural numbers? I think this is going to be pretty nice. All right, whole numbers are all of my counting numbers and the number 0. So it's going to be 0, 1, 2, 3, 4, 5, etc. Okay, so those counting numbers, those whole numbers include the counting numbers. That's why the square you see is inside the whole number square, because the whole numbers include the part that's inside, but they have this little extra piece, this extra 0, okay? Integers are going to be whole numbers and their opposites. Whole numbers and their opposites. So it's going to include all of the counting numbers. It's going to include 0, but then it also includes the opposites. It also includes the opposites. So if I were to think about what it means to be an opposite, what it means to be an opposite, what are the opposites of my whole numbers? Can anyone type in chat and tell me what are the opposites of my whole numbers? Negative numbers. Awesome, Abigail. So we're going to have -5, -4, -3, -2, -1, 0, 1, 2, 3. That was the ugliest 0 I could have drawn. So these are all of my negatives and my positives. But again, notice we're not dealing with fractions or decimals yet, okay? We're still not dealing with fractions or decimals yet. And I say yet because there's still this other piece here. There's something called rational numbers, which is what we actually deal with all the time, okay? Rational numbers are any number that can be written as a over b, so as a fraction, right? As a fraction, where a and b are integers. And this is like the ugliest definition, I know. Integers. And b is greater than 0. So some examples, I'm going to do some examples in green. Some examples of this are 3/4, 5, 0.2, 0.75, -3/8, right? These are all fractions and decimals. So this includes fractions and decimals, but there's actually only includes certain types of decimals. It includes terminating, which means ending, and repeating decimals. So that means it's going to include decimals like 0.3 repeating, or 0.727272, etc., right? Because that has a pattern, it repeats. So rational numbers are any number that makes sense. That's what I like to think about it like, right? 3/4. I know what 3/4 is. It's 3/4 of a pizza. It's 3/4 of a chocolate bar. I know what number would come next in this pattern because it makes sense. 727272. Next would be 7. Next would be 2, right? That number makes sense to me. I know what 0.3 repeating is. It makes sense to me. So rational numbers are those numbers that make sense, okay? Irrational numbers, actually, I'm going to talk about rational numbers one more time because there's one other thing that we need to remember that they include. They also include roots of perfect squares. Includes roots of perfect squares, which I know you just watched this video about rational versus irrational numbers, but I just want to make sure that we went over it. So it includes the square root of 4 because we know that equals 2. Irrational numbers is everything that's not rational. So it's everything that's left over. Any number. Ooh, that's my favorite example, so hold on to that real fast. Any number that cannot be written as a fraction. A over B. So it's everything that doesn't fit here. So this would include decimals that never end. Decimals that never end or repeat. My favorite example, Abigail's right, my favorite example is pi. Because that equals 3.1415926 something something something. And it never ends. Pi never ends. And there's no pattern. We don't know what number comes next unless you've memorized that. There's no pattern to it at all. It's just random. All right. Another example would be the square root of 2. So any root that's not a perfect square, because we don't know exactly what it equals. Or any cube root that's not a perfect cube, because we don't know exactly what it equals. Okay? And the reason that we need to know this information is because we might ask you, is this number rational or is it irrational? Okay, so you need to be able to tell me which type of number it is based on these key facts. I don't need you to be masters of it, but I want us to have a basic understanding that all fractions are rational. All fractions are rational. Okay? Just like all roots of non-perfect squares are irrational. Okay, so again, the reason this is important is I want us to be able to clearly identify a number as rational or irrational. I don't mind if you can't do these parts. I mean, this should be the easiest, but I want us to at least be able to say, I know this number is rational, or I know this number is irrational. I want to show you your homework assignment. So that I can kind of help you get started with it just a little bit as well. So you're going to have two things to do in class today, and I'm going to show you in both of them. I'm going to show you both of them. So the first thing you're going to do in class today is this. Let me share it to you. Did it share to the right Google Meet? It sure did. The first thing you're going to have to do is take the definitions of the words and place them in the correct area. So, I mean, one of them I tried to give away based on the shape of it. You should know where it goes. But the rest, I want you to place where they go based on what we just did with the Jamboard. And I'm going to share the Jamboard with you so that you can look at it from home or after this class, okay? Then you're going to pull these numbers and drag them to where they go. So we know that 0 is a whole number, right? If I look back at the Jamboard, 0 wasn't included in my counting number, it's included in my whole numbers. And because it's a whole number, it's also an integer and a rational. But I want you to put it in the smallest place possible first. Okay? And then you'd keep going, like 5.5 is a terminating decimal, so we know it's rational, okay? So that's what you're going to be doing in class today, is dragging these to where they belong. And you can always ask me questions. I do not mind. You can send me messages like, I'm a little confused about this number. That's totally fine. So feel free to ask me for help. I'm here to help you because I know this is kind of one of those weird assignments that doesn't always make sense. Then after that, you have a homework assignment that's a Google form, and I'd like to show that to you as well. Your homework assignment is going to ask you to choose all the numbers that apply, okay? So 7/8 is a fraction, which means we know it's a rational number, okay? However, let's find a good one. The number 0, right? The number 0, so number 5, is the number 0. 0 is not a natural number, but it is a whole number. It is an integer, and it's rational. So you would actually need to click all 3 of those boxes to get the full credit. Okay? So just keep that in mind. You are able to redo this assignment as many times as you want to get a perfect score. So after you submit it, you can edit your answers and keep doing it till you get a perfect score. And you have all weekend to do it. Okay?